So for this question, we need to integrate x cosine x. Now, in previous videos, we've looked at the reverse chain rule, integration by substitution, these kinds of methods. However, for this type of question here, it's going to be a bit more tricky, okay? Because how can we integrate this? We can't really use any of those ways. And the reason for that is because, well, even if we use substitution, there's not really anything we can really do, because there's no really relationship between the x and the cosine x. So what we can do is we can use integration by parts. So what that states is that if we have the integral of u dv over dx with respect to x, that is equal to uv minus v du dx with respect to x. So effectively, when you have something like this, you have like two x variables. We just need to choose one to be the u and one to be the dv. So for example, in this question, let's make x u. So let's make u equal to x. And then let's make dv over dx. Let's make that equal to cosine x, okay? And then we just need to work out our du over dx and work out our v. So if we do du over dx first, well, that would just be du over dx. Well, that would just simply be 1, okay? We're just differentiating x. With respect to x, that will just give us 1. Now with dv over dx, we want to get v. Now to get v, we just need to integrate cosine x. So if you integrate cosine x, you get sine x. And now that we've done that, all we need to do now is just apply that formula, the uv minus the integral of v du over dx, and that will give us our answer, okay? So if we do that now, what do we get? Well, we would get a u times v, so in our case that would be an x sine x minus the integral of v du over dx. So for us, that would just be sine x times by 1, so that would just be a sine x, okay? And now all we need to do is integrate this. So we would get an x sine x, and then if we integrate just a sine x, well, that would be a minus cosine x. Now, and then with a minus times a minus cosine x, that would make a positive cosine x, and that would be our answer. And again, because it is undefined, we need to add our c. So our answer would be x sine x plus cosine x plus c. So for this question, we need to integrate x squared ln x. Now for this question, while we can make any of the values u and any of them dv over dx, you want to choose the one which is going to be easiest for you to solve. So in this case, while we could have ln x as the dv over dx, integrating ln x will be a bit difficult right now, right? It will be easier if we differentiate ln x. So therefore, we will make u equal to ln x. That way we can differentiate it. And therefore, that means that we'll have the x squared as the dv over dx. So now if we integrate, if we differentiate ln x, that will be du over dx, that's equal to 1 over x. And then if we integrate x squared, that would just be x to the power 3 over 3. And now we just apply that formula again. So uv minus the integral of v du over dx with respect to x. And if we do that, we get u times v. So what would that be? That would be a x to the 3 over 3 ln x. That would be minus a v times du, the integral of v times du over dx. In this case, that will be a x to the power 3 over 3 times by that 1 over x. That would give us a 1 over 3 x squared, okay? And then we want to integrate that now with respect to x. And if you were to work all this out, you would get a x to the 3 over 3 ln x. And then if you integrate 1 over 3 x squared, you'd get the power will go to a 3, then you divide by 3. And what would that give us? That would give us a minus x to the power 3 over 9, okay? And then again, it's undefined, so we plus our c value. Now in the previous question, we spoke briefly about integrating ln x, and it's a bit more challenging. Well, now we're going to integrate ln x using integration by parts. So we need to integrate with the limits of 2 and 1, integrate ln x with respect to x. Now, if we want to do this using integration by parts, then how can we do this? Well, what you can think of is that ln x, effectively, you can consider it as it's like it's being 1 times ln x, right? And because of that reason, what we can do is we can make u equal to ln x like before, and we can make dv over dx equal to 1, okay? Because it's like saying 1 times ln x. So because we can do this, therefore, if we differentiate ln x, well, that will just be 1 over x. And if we integrate 1, that is just going to be x. And now we can just use the integration by parts formula to work out what the integral of ln x is. So if we do that, what do we get? Well, we get u times v. U times v would be ln x times x, so we can say that's just x ln x, okay? Minus the interval of v times du over dx. Well, that's just an x times a 1 over x, which is just a 1. And that's with respect to x. And therefore, that would be a x ln x, and if we integrate 1 again, we'd get a minus x. But in this case, we have limits, so which means we have the limits of 2 and 1. So if we put our limits in, okay, what do we get? Well, we would get a 2 ln 2 minus a 2, okay, and that is minus that's just a 1 times a ln 1, okay, minus a 1. Now, that's a 2 ln 2 minus 2. Now, a ln 1 is just 0, and therefore we would have a minus times a minus 1. So we're just left with a plus 1 here. And then if you work that out, you get a 2 ln 2 minus 1. Okay, that would be our answer in this case. So what does that tell us? That tells us that the integral of ln x with the limits of 2 and 1, that is equal to 2 ln 2 minus 1. So for this question, we need to use integration by parts to integrate x cosine 4x dx. So for this one, I will make u equal to x, and I will make dv over dx equal to the cos for x. So if we differentiate this, we get du over dx, that is just equal to 1. And for v, we need to integrate the cosine 4x, which would be a 1 over 4 sine 4x. And then we just apply the formula. So if we do uv, that would just be a x times a 1 over 4 sine 4x. So that would be a 1 over 4x sine 4x minus the interval of v times du over dx. In our case, that's just 1 over 4 sine 4x times 1, which is just 1 over 4 sine 4x, okay, with respect to x. And then if we are to work that out, what do we get? Well, we would get a 1 over 4 x sine 4x. And now we need to integrate that 1 over 4 sine 4x. So if we think about it, we know that if we are integrating, that 4 is going to come out, but it's going to be like the reciprocal, right? So it's going to be another 1 over 4 is going to come out. So we'll get a 1 over 16. But then also that sign is going to change to a minus cos. And then, so it'll be a minus times a minus cos. So that will make a positive value. And then obviously we're going to have the 1 over 4 times by another 1 over 4. So we get a 1 over 4 cosine, not 1 over 4, my bad, 1 over 16 cosine 4x. And then that would just be plus c. So for this question, we need to use our previous answer to work out the integral of x squared sine 4x. So for this question, I'll make my u x squared, and I will make my dv over dx, that will be equal to a sine 4x. So if we integrate x squared, not integrate, differentiate, that would be a du over dx, that would equal 2x. And if we integrate the dv over dx, we get a minus 1 over 4 cosine 4x. Now if we apply the formula, we get a u times v, which would be a minus 1 over 4x squared cosine 4x minus the integral of v times du over dx. So we have the minus 1 over 4 times cosine 4x times by that 2x. That would be a minus 1 over 2, okay, minus a half x cosine 4x, and we need to integrate that with respect to x. Now, as you can see, we have to integrate minus a half x cosine 4x. That looks very similar to what we previously had to work out, which was x cosine 4x. So what we can do is, if I write this down here, what we can do is we can, if I do this, we can take out that minus a half. You take out the minus a half, now you're left with a positive a half integral of x cosine 4x. Now that's exactly in the same form as the previous question. So now we can use our previous answer to then just solve that integral, because we already know what x cosine 4x is from the previous question. So if we use that, therefore, what do we get? Well, if we look at our previous answer was 1 over 4x sine 4x plus 1 over 16 cosine 4x. Therefore, the answer for this question, it will be a minus 1 over 4 x squared cosine 4x, that stays the same, plus a half of the integral of x cosine 4x. So that will be a 1 over 4 x sine 4x plus 1 over 16 cosine 4x. And then we're going to have a constant value in this type of question, so we can just add the plus c here. And now if we simplify this down, what do we get? We would get a minus 1 over 4 x squared cosine 4x plus 1 over 8 x sine 4x, and then plus 1 over 32 cosine 4x, and that is plus c. And then that will be it for this video. I hope you enjoyed this little video on integration by parts. If you want to go over any of my other integration videos, feel free. I'll put like the playlist maybe in this video now. So please feel free to watch any of the other videos. But I hope you enjoyed this lesson, and I will see you soon.